So, good morning. Yes, good morning, everybody, and welcome to this session on faster SQL performance using our Velocity IO reduction software. My name is Spencer Allingham. I'm the Technical Director for Europe, Middle East, and Africa, which I guess is a fancy way of saying that if you have any questions as we go through, I should have a fighting chance of being able to answer them. So feel free as we go through, if any questions arise, please do put them into the Q&A box in the WebEx window, and at the end of the presentation I'll have a little Q&A session, and I'll do my best to answer any questions that anybody has as we're going through. So on with the presentation. So this first slide is really about us as a company, and I don't want to bore you with too many details here. I'll just pick out a few key points because I know you're probably all keen to understand a bit more about the technology and what we can do for your SQL servers and the performance of SQL and other systems that you have running in your environment. So the first thing is, we're not a new company. We've been around for over 30 years. And I think 1983 we started. We've been a Microsoft partner since the mid-90s when they bought out Windows NT 4, and really have established ourselves as one of the leaders in the field of optimizing the performance of storage technology that you would connect to Windows systems. About 4 years ago now, Gartner gave us the Cool Vendor badge that you can see on the page, really for what we were doing to help improve performance in the virtualization space. So think VMware, Hyper-V, that type of technology, and what we could do to reduce I/O and improve performance there. And just at the end of last year, just a little before Christmas, Microsoft gave us this I/O reliability certification. And this is basically certifying our software for use with SQL Server. SQL Server 2016 was what they tested in Azure. And one thing that was very cool was, aside from being able to jump through all the hoops required to get that certification, we actually proved that they were able to get 28% more SQL transactions done in the same amount of time, just simply by making everything more efficient and faster. Some of the caching technology that I'll mention in a moment is actually also licensed to some of the top hardware manufacturers. You can see them listed here, and they use this caching technology to make some of their products run faster and, more importantly, stay running very, very fast. So anyway, that's enough about us as a company. I'll move on, and we'll talk a little bit about here. So we did a survey. Asked several thousand IT professionals like yourself some questions related to their IT environments. One of them was this one. So the question was, regarding your I/O intensive applications running on SQL or with a SQL backend, do you experience staff or customer complaints due to sluggish performance, where things not running quite as fast as they should or quite as fast as they used to? Now, thankfully, the majority said, no, everything's running fine. But 27% of the respondents said, actually, yes. Some of our customer-facing applications or user-facing applications are seeing this sluggish performance because SQL is not really performing as we had hoped or as fast as it could. And that was very interesting to us because we can help most of these people get all of the performance that they've paid for when setting up their environment. And I suspect even some of these people that responded no or undecided would also like to see faster performance, even if it's not causing business-facing issues right now. Who wouldn't want to have faster SQL transactions in their environment? So let's talk a little bit about what tends to slow SQL down and other types of servers as well. Think file servers, application servers, document management systems, especially when all of these systems are sharing the same shared storage at the back end, typically a SAN storage or some sort of network attached storage like that. So on the screen here, we have a rough representation of a virtualized environment. In the middle here, we have our hypervisor. That's our physical host. So that could be our VMware ESXi box, or a Windows server with a Hyper-V role, or KVM running on Red Hat. Doesn't really matter. It's hosting a number of virtual machines. So these could be running instances of SQL, could be a file server, a SharePoint server, an application server. They're all generating storage I/O traffic that gets funneled down through the physical host and then onto the storage at the back end. Now, this is what it looks like when everything's working well and running efficiently. And by that, what I mean is you have the least number of storage I/O packets, each one carrying the most amount of data, or a good payload of data. And what that means is when they arrive down at the storage controller here on the back end, the storage controller has the opportunity to create nice, large, unbroken stripes across its media using the least number of storage level operations. So that's a very efficient way of moving data between server and storage and back again if that data needs to be read later on. But when you're running Windows in these guest Windows machines, or running Windows on a physical server, this is not typically the I/O profile that you're actually going to get. What you'll actually get looks more like this. And what's happening here is that same amount of data is being split up into many more, much smaller I/O packets, carrying much less data. And this becomes far less efficient. Okay, what's happening here is as your users or applications mature the NTFS file systems mounted in these Windows machines, as they create new files, they delete files, they extend the size of files, and they move files around, what naturally happens is the free space on those volumes becomes more and more fragmented into smaller and smaller free space extents. So now you have a situation where the Windows write driver is being given a right to perform. It goes to the Windows free space cache and says, hey, free space cache, I need to do a write. Where's my next available free space extent? It gets given that address, it starts writing out its data, and then it finds, I don't actually have enough room to complete writing all of this data. So I'm going to split my I/O. I'll send the data that I have already written on down to the storage. I'll go back to that Windows free space cache, find my next available free space extent, and I'll continue writing there. So it starts writing and then finds again, there's still not enough room to complete this write. So I'm going to split the I/O again, go back to the Windows free space cache again, and basically repeat and repeat and repeat until it has been able to complete that write. Now, in the real world, what that means is that an average gigabyte of storage I/O traffic that should complete in maybe 2,000 or 3,000 I/Os is now taking 30,000 or 40,000 I/Os, or in some cases even more. And that's a much less efficient way of getting that data down to the storage. It's a bit like saying, okay, on this side of the room I have a liter of water, which is my data. And I need to move it to this side of the room where the storage is. It's a lot more efficient to make one trip across the room with a liter-sized jug than it is to take that same amount of water and pour it into lots of tiny shot glasses, and then take the first 2 shot glasses across the room, and then come back and take the next 2 shot glasses across the room, and then come back and take the next 2 shot glasses. You see how these small shot glass-sized I/Os make this whole environment work so much harder than it needs to process that same amount of data. You know, each storage I/O request that gets generated takes a measurable amount of time and resource to process. And the more it has to keep going back to that Windows free space cache, the more performance you're losing. We call it the Windows I/O tax, as in a tax on your performance because Windows doesn't play nicely with the storage, especially in a virtualized environment. I mean, the performance loss from split I/Os is going to happen whether you are using physical servers with direct attached storage or if you're in a virtualized environment. But in a virtualized environment, that performance penalty gets amplified and made worse by something called the I/O blender effect. And what's happening here is you have these small fractured I/O packets still all being funneled down through the physical host. But the physical host acts like a blender, and it mixes these I/O streams together so that what comes out between the physical host and the storage on the back end is now a chaotic mess of small, fractured, and now very randomized I/O streams. By the time they reach the storage controller, they couldn't be less storage friendly. You know, the storage controller doesn't understand the relationship between the packets that it's receiving because it's too far abstracted away from where the I/O is coming from at the top end. So as far as the storage controller is concerned, it's only getting the data in very small packets at a time. It can only now create very small stripes across its media, and that means a lot more storage level operations are required to process that same amount of data before the storage transaction can be acknowledged and it say, okay, operating system, I've completed the write. And this also affects subsequent reads as well. If you've only created very small stripes across your media, it means a lot more storage level operations are going to be required to read that data and then present it back up the stack as well. So what do we do to solve this problem? We have I/O reduction technology. It is 100% software-based. You don't need additional hardware to make this work. It'll run on your existing infrastructure that you have already bought and paid for. And what it is a very simple piece of software, very lightweight, that sits in these guest Windows operating systems or Windows Server if it's on a physical environment. And it adds an extra layer of intelligence to the Windows write driver. So instead of having to go back to that Windows free space cache to find yet another free space extent that's too small, it says, hey, write driver, actually start writing here on the NTFS volume where there is a large enough area of free space to write that data into without having to split it up, or split it up the least. And of course, the software can quietly, automatically, in the background, help to create these nice large areas of free space that makes it easier to write into as well. And it will only use otherwise idle compute resources to do that. It will never compete for resource with any other processes that you have running or any other applications that are there in the environment. So what that does is removes a great deal of this excess unnecessary storage I/O traffic and displaces it with these larger I/Os that are carrying more data, and so fewer I/Os are required. So you get back to this type of situation, this type of efficiency. What we then do is reduce the I/O load even further on the back-end storage by using a RAM caching technique. So we can use some of the idle available memory that's not being used by anything else that's sitting here in these Windows VMs and set up a RAM cache from there where we can satisfy a good percentage of the read I/O traffic so that no longer do all of the reads have to go out and be satisfied by the storage at the back end. Now a good percentage of them can be satisfied from the RAM cache in these operating systems. So the effect there is twofold. First, it's a further reduction on the I/O traffic and workload that the back-end storage has to deal with. And that amount of read I/O traffic that can come from the RAM is satisfied at the speed of RAM rather than the speed of the media in the back-end storage. And that's quite important for application performance, especially for things like SQL Server. You know, RAM is roughly 10 times faster than flash and SSD storage, and it's hugely faster than spinning tin disk technology like SAS drives or SATA drives. So the more of those reads you can satisfy at the speed of RAM, that can only help application performance. Things like SQL, things like file servers, application servers, and so on. And that becomes really important if you have a number of these different machines that are all sharing the same storage. Let's say, for example, this VM was running SQL and this VM was running the application which uses SQL as the back end, and they're doing an amount of storage I/O traffic, but then you have a very busy file server or a very busy backup server all sharing the same storage. Well, these two machines could be slowing down your SQL Server and your application server because they are keeping the storage very busy. So if you put the software onto all of these machines, you reduce the storage I/O workload the most and improve performance the most so that all of these machines benefit. I hope that makes sense. So quick recap. We have large, clean, contiguous or unbroken writes, which have a greater payload of data with every storage I/O operation. That hugely increases the efficiency of data moving between server and storage and back again. We can cache hot reads from some of the idle available memory that you already have sitting there in those machines. We have a benefits dashboard that will actually show you how much storage I/O time is being saved by eliminating all of this traffic from having to go out to the back-end storage. And finally, we guarantee to solve the toughest performance problems, or quite simply, we'll give you your money back. Now, there are not many software companies that are willing to provide that type of guarantee, but hopefully that's an indication of just how confident we are that this stuff works. You know, we've been working on caching technology, for example, for the last 30 years. So we know this stuff works. And we just want you to try it. Don't take our word for it. Now, I'm not saying that you have to make any kind of upfront purchase commitment. You don't. And so far, I don't think anybody has taken us up on that guarantee and had their money back. You know, everybody's been quite happy with the software that they've seen and the gains that they've got. We do provide for free 30-day trialware that will run fully featured in your environment. So you can use that before any kind of purchase commitment. But that's really there just to show you how confident we are that the technology works and can work for you. So this is an example of that benefits dashboard that I mentioned just a moment ago. And this is the sort of average results that you would expect to see on a SQL server where you could leave 4 GB of available physical memory. Now, with SQL, as I'm sure most of you know, it's very memory hungry, almost memory addicted. So it'll, if uncapped, chew through all the available memory on a SQL server. And what it's doing is using that memory for its own form of caching called buffering. Unfortunately, though, it doesn't do a particularly good job of making good use of that RAM that it's taken. So if you cap the amount of RAM that SQL can take for itself and force it to leave at least 4 gig of free available physical memory, that would give us roughly a 2 GB cache size. And then you would see results like this. And if you needed a greater amount of performance, well, give us more RAM, and we can then have a larger cache size. And that's really where we start providing these 2 times faster SQL transactions and you know, much faster SQL servers. So on this particular server, in the last 3 weeks, we eliminated over 9.5 million storage I/O transactions from all having to go out and be dealt with by the back-end storage. That represented 64% of all of the reads not having to go out to the back-end storage and about 30% of all of the writes. In terms of storage I/O time saved, accumulatively, that was just over 20 hours of storage I/O time. So that's 20 hours of storage time that the storage didn't have to spend processing these 9.5 million I/Os that we were able to eliminate from having to go out to it. That means that the storage now has more time to process the workload from very storage traffic hungry applications like SQL so that it can now get more work done in the same amount of time, more SQL transactions per hour, per day, quite simply because it's not having to wait so much on the storage before being able to get on with its next transaction. What that additional I/O or IOPS headroom means that we're handing back to the environment is that there's effectively less in the pipe going between server and storage, less I/Os per second at any given moment. So that additional I/O headroom means that, yes, in addition to being able to have things like SQL run faster and do more transactions, that extra IOPS capacity means that you can host more machines more users, more workloads, more instances of SQL over that same shared storage than you otherwise would be able to do. I hope that makes sense. So let's take a quick deeper dive into the write IO reduction technology. It's probably important for me first to mention what we're not doing. We're not touching the data in a storage IO packet at all. We're not trying to do anything clever like compression or deduplication or anything like that. It's still the standard Windows write driver creating a standard NTFS storage IO packet and then sending it down the stack to the storage controller. Okay, that's important if you're concerned about maintaining ACID compliancy, which I know a lot of SQL DBAs are. So we're not trying to do anything clever like that. We're simply giving that Windows write driver an extra layer of intelligence so that it can make better choices about how and where to write that data so that we can prevent and avoid most of these split IO situations and replace them with far fewer IOs that carry a greater amount of data for improved efficiency. On the read IO reduction, I mentioned we're using this RAM cache. We dynamically size the cache, so the cache size will grow and shrink automatically depending on the resource requirements of everything else that you have running on the machine. So let's say, for example, you were to spin up a new process that needed a new working set of pages of RAM. We would shrink our cache, hand enough pages back to non-paged pool to make sure that we never compete for RAM with anything else. We'll even shrink our cache to a 0 size if need be and still leave a gig and a half of RAM free just to make absolutely certain that we are never the cause of any kind of memory starvation situation. But where you have some RAM free, we can use some of that to establish that RAM cache and really boost performance by having those a good percentage of that read traffic satisfied at the speed of RAM rather than the speed of the media in the back-end storage. And we've got some very cool telemetry as well that we use to figure out what needs to be in the cache and when. So this learns over time what the main applications are that are in use on a machine, what type of files are being accessed, what type of IO streams are being generated, and at what times of the day, the week, the month, the quarter. So we can use that intelligence to become very clever about what blocks of data are hot and need to be in the cache, and more importantly, when. And it can also focus on the type of storage IO traffic that tends to slow storage down the most, which tends to be the very small, very random read IO traffic. So we can focus on getting that into the RAM cache more often and holding it there for longer for even greater efficiency from the caching. So what do our typical customers look like? These are all representative of case studies that we have available on our website at condusiv.com. So if you wanted any light bedtime reading, you're very welcome to jump across there and pull some of these down. I won't bore you by going through all of these, but I will pick out a couple if I may. This is a very cool one down here on the bottom left. Bell Mobility, they're a telecoms company in Canada. We were able to reduce the IO traffic going out to their SAN storage by 61%. And that gave them SQL transactions that were 3 times faster. No additional hardware required. All they did was install our V-locity software. And we optimized the traffic on their existing infrastructure and basically gave them all of the compute that they've paid for rather than having to waste 30 or 40% of their compute to this excess unnecessary traffic that, quite frankly, doesn't need to happen. Another one here in the middle, ASL Marketing. They were doing SQL batch imports. They were taking 27 hours, massive imports. We were able to drop that to just 12 hours. Significant reduction in the amount of elapsed time there. Again, no additional hardware required. And yeah, there's another one up here, Krista's Health. This is a personal favorite of mine. These guys had basically virtualized their medical records application. They were running it on physical servers with direct attached storage, but they virtualized it and found that as they did so, their performance was starting to tank. I mean, it was really starting to get sluggish. Now, in a healthcare or hospital type environment, you can't afford that. You really can't afford to have somebody stumbling into the emergency room, bleeding from the head, getting up to the counter and being told, "Oh, I'm sorry, you'll have to wait because the computer's running slow." Especially in somewhere like America that's very litigious, you cannot afford for the computer system to be blamed for something like that when you've got somebody in medical need. So these guys were about to pull the trigger on a $2 million replacement for their back-end storage to fix this. They were going to overbuy and over-provision from a hardware perspective to be able to cope with all of this excess unnecessary storage transaction that was really slowing down the environment. But they put our V-locity software in there first and found that we were able to give them back so much performance on their existing infrastructure that they actually canceled that $2 million purchase order with NetApp. Now, the rep from NetApp was very, very cross, as you could imagine. He came up and found us at VMworld over in Vegas, and he vented. He was really, really cross. Now, the good news for him is it turns out they are still going to purchase that new NetApp filer. But they're able to defer that capital investment for a number of years and budget for it properly, rather than having to find $2 million now as an emergency break-fix solution. So that's a great example of where we can help extend the life of the existing hardware that you already own. If you're expecting to refresh it or replace it in 3 years, well, maybe now you can do that in 4 or 5 years and sweat those assets for a longer period of time and increase the return that you made on that investment in the hardware. Keep it running for longer, do more with it. Again, more customer examples. Again, I won't bore you by reading through all of these, but this is an interesting one down here, Agrium. Their SQL databases began to slow down, and they were only 3 years into their SAN's life cycle, which they expected to get 5 years from. So they're 3 years in, it's already starting to run slowly, and it's too early. They haven't budgeted for a hardware refresh yet. We doubled the performance on that existing environment, and not only are they now going to get the full 5 years out of that, they're now talking about perhaps running that for 6 or 7 years and extending its life cycle. Another one here, Admiral Metals. Their users would experience lag under peak load on their in-house written application when they were querying metal prices from the SQL database backend. We doubled the SQL performance with our software, and all hint of lag disappeared. They were very, very pleased. And we hear this sort of thing time after time after time. All you need to do is install the software and try it and see what difference it can make in your environment, with your real-world hardware, with your real-world workloads. Now, I don't want you to take my word for this. I want you to get hold of a copy of the software and try it for yourself. That's why we will provide the 30-day trialware to anybody who wants it. That's why for everybody who's attending this session, we're going to give a full copy of the software that you can put onto one machine and see how it works and see what it can do for you. Now, in my opinion as an engineer, putting it onto just one machine is not the best way of running a proof of concept. Yes, you'll be able to prove that the software works as advertised and that it reduces the I/O load being generated by that one machine. But if you really want to get the full performance and power out of the software, what you want to do is get that 30-day trialware and put it onto as many Windows machines as you can that share that same back-end storage. Because if you do that, then you are reducing the I/O traffic and the storage workload the most, regardless of which machine's generating it at any given time. And then from the point of view of the storage, it's now doing the least amount of work. You have all that additional I/O headroom being handed back. And that's really where you're going to get the most bang for buck. So in terms of next steps, we can certainly provide you with that 30-day trialware. Just reach out to one of our reps. You can request it on our website, and I'll provide you with my email address as well. So you can reach out to me personally in a minute. I'll put that into the chat box shortly. Where some people like to start as well is by using a free I/O assessment tool that we provide. So this is completely non-disruptive. You don't have to install anything on any live servers. You certainly don't have to reboot anything. You just install it onto a machine that can see those live servers on the network. And then it uses Windows Management Instrumentation, or WMI, which is a part of the Windows operating system, to grab some of the counters and metrics and measurements that are already there inside every installation of Windows. They normally get used by things like Windows Performance Monitor or Resource Monitor, or sometimes even the Task Manager. And we'll grab these metrics, put them into a simple text CSV file, which will then analyze to produce an easy-to-read report like this. And if I flip over to the next page, you can see the computers that get measured get color-coded like a traffic light. So red if they're being critically impacted by storage performance problems, yellow if they're being moderately impacted, and green if actually they're running just fine. And then we'll list out the 11 different metrics that we've measured, so things like the amount of storage I/O workload that's being processed, the average I/O response times, how long is it taking to satisfy an I/O request at different times of the day. We'll show you what the I/O queue depths look like. You really don't want to have large I/O queues building up, where you've got a situation where some I/Os are having to wait on other I/Os to be processed first before they get their turn. It's like people queuing up to get on a bus. They can't all get on the bus at the same time, so a queue naturally forms, and the ones at the end of the queue have to wait longer than the ones at the front in order to be satisfied and be processed. We show you how many split I/Os, those performance-losing split I/Os, are being generated and at different times of the day. You can see the different times of the day on this graph down here, so see when you're being affected more than other times of the day. We can show you what the I/Os per second look like, what the I/O packet sizes look like. We can show you whether you're suffering from that I/O blender effect in a virtualized environment, and so on. Then at the end, you have a little conclusion panel that'll say, Mr. Customer, your potential for performance optimization with software like ours is either high, medium, or low, depending on what we found. And then we'll explain that conclusion with a few bullet points at the end. So this is a really great way of figuring out and answering questions like, do I have storage performance problems? If I do, what are they? What machines are they occurring on? And at what time of the day? And the great thing about this is it literally takes a minute to install and set running. In fact, if I show you an example here, this is the actual tool itself. So to set this running, in the first box, I would put in the machines that I want to measure. I would recommend maybe measuring 10 of your heavy storage hitters. So here you could put in fully qualified domain names. So machine1condusiv.com, so a fully qualified domain name, or an IP address, and so on. Just list them out here. Then you say how long you want to measure for. So for as little as 1 day or as many as 7 days. I normally suggest about 10 machines over 2 or 3 days, and you tell it what day of the week to start measuring. So I know the beginning of my week's heavy, so I'm going to set it to Monday and have it monitor Monday and Tuesday. Or you can say, I want it to start right now. And then finally, you put in some domain account credentials, and I would recommend that you use an account that's a member of domain administrators so that you know it's got enough access rights to pull that WMI data from the remote systems. And then you hit start, and that's it. You'll see a little countdown timer as it's either waiting to start the data collection phase or whilst it's in the data collection phase. When that hits 0, you see the report, and that's it. And you're very welcome to share that with us and have an engineer like me analyze that data as well and step through the results with you. That's completely free. You're very welcome to take us up on that too. So that being said, I'm going to stop sharing my screen and see if we have any questions for the Q&A session. So let's see. Okay, Cedric says, great tool. I'm not sure whether he's talking about me, the IO assessment tool, or the software. Hopefully, it's the software or the IO assessment tool. Okay, so one question that I do have that's come through is, what about AWS? So I've been explaining how this can help things run faster, especially when you're thinking about things like SQL Server and other busy applications that use the storage a lot. But yes, AWS, there is a play in AWS. Clearly there's a performance play, because the more you can use RAM rather than the back-end storage, that's going to help performance. But with AWS, you are partly charged and billed based on the amount of storage throughput that the storage has to process. And of course, our software is reducing the amount of storage workload that actually has to go out to the storage. You know, let's say you can eliminate, as in that example, 50 or 60% of all of the reads and about 30% of all of the writes from having to go out to the storage. That's a significant reduction in storage throughput, and that should represent a pretty reasonable saving on your Azure bill each month. And it's similar in other types of public cloud. Azure, for example, from Microsoft, they work slightly differently. If you're using standard managed disks, which is your SAS drives, for example, again, you're partly billed on every 10,000 storage transactions that the storage has to process. So that's a read or write I/O, that's a list, a put, a get, a delete. Those are all storage transactions. And 10,000 sounds like a lot of storage transactions, but I can promise you it's not. One example from a customer recently, we had the software running on 47 of their virtual machines. We were able to eliminate over 1.5 billion storage transactions from going out to the storage in 1 week. 1 week. So is there a play for our software in public cloud like AWS and Microsoft Azure? Yes, there is, both a performance play and potentially a billing one as well. Right, so Herman asks, is the assessment software tool intrusive in any way whilst running? No, it's not. It's very lightweight, and as I mentioned, you don't actually install it on any live servers. You just put it onto the machine that can see those machines that you want to measure on the network, and it's no more intrusive than using Windows Performance Monitor to measure those metrics on those remote systems. It's very, very lightweight. Okay, Herman also says, is it correct that your product works in a similar way as BPE, Buffer Pool Extension? Okay, forgive me, I'm not familiar with Buffer Pool Extension enough to be able to answer that. It's not often that somebody catches me out with a question like this, but Herman, you have done it today. What I'm not going to do is try and bullshit my way through an answer. I would never do that as an engineer. So what I'm going to do, if it's okay, is take that offline. I will find out, speak with our developers as well, and I will get back to you in an email and let you know the answer to that. In fact, let me just copy that, put it into a notepad, and I will make sure to follow up on that for you. Okay. Right. So, one thing I forgot to do that I mentioned, I said I would put my email address in the chat box for everybody. Let me do that now at condusiv.co.uk. So that is my personal work email address. You'll make a note of that. If you want to get hold of the software, reach out to me. If you want the IO assessment tool, reach out to me. If you have any questions after this session, feel free to reach out to me, and I promise to respond to every single one of them. So Hod Malkiel says, what are the benefits on physical machines with local SSD disk? That is a great question. Okay, so Our software will recognize a direct attached SSD, and it has specific technology in it to work with that SSD. Now, of course, the caching, if we can use RAM for a good percentage of those reads, that's roughly 10 times faster than your SSD storage could deal with anyway. So from a performance point of view, that's great. But one of the dirty secrets about SSD storage is that whilst the read I/O traffic will always stay fast, the write I/Os and the write traffic will tend to degrade over time. That performance will become slower, and it can slow up to sort of 80% of that day one experience. And what's happening there is you're getting more and more erase write cycles being required as that data is being written out. So forgive me if I'm teaching some of you stuff you already know, but with the way that SSD technology works, you have a number of NAND cells in the SSD. So think of that like a big field full of buckets into which you can put data. Let's say one of those buckets is 40 kilobytes in size, and you've already written 20 kilobytes of data into that NAND cell bucket. And you want to put another 20 kilobytes. You can't, as you can with spinning disk, just start writing next to it in the next cluster. What you have to do is copy that existing 20 kilobytes out into a buffer. You have to erase that NAND cell and make it a virgin NAND cell again. Then you put the new data with the old data, and you then put that back into the NAND cell. The more of those erase write cycles that have to be done during a write, the longer that write is going to take. So we have specific technology in our products, in both the Diskkeeper technology and V-locity, to recognize a direct attached SSD and prevent a lot of those erase write cycles from happening. We do that by having it write to the larger areas of free space first, which are more likely to be virgin NAND cells. And then when they all get used up, we'll shift the goalposts so that it can start using the medium-sized NAND free space extents, and so on. So not only does that help to prevent the write performance from degrading, it also actually extends the life of that SSD as well, because it's having to do fewer erase write cycles. So I hope that answers that question about SSDs. Okay, so Hod also asks, what happens on a power failure or operating system crash? Will there be data loss? The short answer to that is no, there won't be. Now, I could tell you true things like every version of our software actually gets certified by Microsoft before it gets released to the public, which is true, it does. But the reason why you're not going to suffer any further data loss, whether our software is present on a system or not, is that any writes that occur go straight out to the storage. Just the same as if our software wasn't there. There's no delay or buffering of that write, it goes straight out to the storage. All we're doing is allowing that Windows write driver the extra intelligence to make better choices about where to write it. So any data that gets written goes straight out to the storage. The RAM cache is only caching read I/O traffic. We're not trying to cache writes at all. So again, if somebody trips into the data center, heaven forbid, and trips over a power cable and causes an unexpected power loss on a server, you're not going to lose any more data or suffer any more issues than our software being there or not. So I hope that answers that. Daniel Jacquet, hi Daniel, how are you doing? He says the assessment tool may need a lot of space to store logs on 1 week for 10 servers. Not a huge amount, if I'm honest. Let me see if I can get an example. And I'll show you. So this file is 688 kilobytes in size, and that contains data for, I believe, about 10 systems. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, about 15 systems. So That's 15 systems over 1 day. So if you were to multiply that for 7 days, which is the maximum that you can measure, you'll get a rough idea. So we're not talking about a lot of space to store those reports. They're really not big. You know, that was, what did I say it was? 688 kilobytes in size. So yeah, multiply that by 7 and you will have roughly the file size. Not huge. So I hope that answers that. So Axel says, big question. Would you consider or recommend to virtualize a file server for shared video storage to a VM and using, e.g., Intel Optane P900 cards in a RAID 0 mode to use as an I/O cache using Diskkeeper 16 and put V-locity on top to optimize writes? Or are the write optimizations identical to those in Diskkeeper 16 already? Does that make sense? Axel, believe it or not, that does make sense. And good question. Okay. So first of all, let me make a distinction between Diskkeeper and V-locity. The two products are basically the same product. They share pretty much the same code base. They share the same technology. They share the same features. The distinction is more of a marketing one, if I'm honest. Diskkeeper for many years, going back to the mid-90s, was known as a solution for physical servers and direct attached storage. That's how people remember the Diskkeeper brand. You can use Diskkeeper in a virtual environment, but we really market it for physical Windows servers, and we have the V-locity brand for virtualized environments. But the two products do the same job. So the question is, should you install it at the guest VM layer or at the physical host layer, or both for best results? The answer to that is, in a virtualized environment, you would put it into the virtual machines only. That's where you're going to see the most benefit. That's where you're going to be able to have that RAM cache as close to the applications that are reading data as possible. If you put it down at the physical host layer, you're abstracting it away from those applications. More importantly, it's at that guest Windows layer that those storage IOs get split. Okay? If you try and prevent or avoid that split IO traffic down at the host layer, well, you can't. It's too late. The traffic's already been split. So my recommendation is to put the software into the guest Windows operating systems and have it operate there. And make sure if you've got a particularly read-heavy workload that you've got enough memory free so that we can have at least a 2 or 3 gigabyte cache size, and then you're going to see a really good reduction in that traffic going out to the back-end storage. So I hope that answers that. So Stephen McKinstray says, where does the software get installed? Purely on the VM guests, or is there something to go on the physical hosts? Well, Stephen, I hope I just answered that one, but just to reiterate, put it into the virtual machines. That's where you're going to see the most bang for buck. You can install it on a physical Windows server with a Hyper-V role. It is possible to do that, but you're not then avoiding those split IO situations. Get it into those guest Windows VMs. That's where you're going to get the best result. Okay, I think, let me see if there's any other questions. Yes, there's some more questions here. Goodness, you guys are gluttons for punishment. Let me flip over to this Q&A box here. Okay, so Jicky Lee says, will there be a conflict with other softwares we have on the system, for example, Perfect Disk? Yes, there could potentially be. I wouldn't recommend using Perfect Disk and Diskkeeper or V-locity on the same machine. They're both trying to do the same sort of job, and in terms of preventing the split IOs. In their case, they're preventing the split IOs that would cause file fragmentation, and they have a reasonable defragmenter as well. So no, I wouldn't recommend having both trying to coexist on the same server. It's like trying to have 2 antivirus products on the same machine. You wouldn't typically tend to do that. So, okay, I hope that answers that one. So, I suppose I should mention, I don't normally sort of put our software up against other vendors' software, but I guess some of you might be thinking, well, if I have perfect disk, why would I want to use Diskkeeper or Velocity? The short answer is I don't believe that perfect disk has the same type of RAM caching technology to boost application performance. Feel free to correct me on that if I'm wrong, and if there's anyone from Perfect Disk listening, feel free to chime in as well. I'd be very happy to have a chat about that. But I'm reasonably certain they don't have the RAM caching. They're only trying to avoid those split IOs. Andrew Kinghorn says, what's the difference between Diskkeeper 16 versus Velocity? Actually, very little difference, if I'm honest. I already mentioned that the main difference is really more of a marketing one. The user interfaces are slightly different, and you do get an additional report in the Diskkeeper software that you don't get in Velocity. So in Velocity, you get that dashboard report that will show you. In fact, if I bring up my copy of Diskkeeper here, I'll show you. It'll be easier. So this is Diskkeeper running on my machine. Hopefully you guys, oh no, you can't see that because I haven't shared the screen again. Let me do that quickly now. Nearly got caught out then. Okay, hopefully you guys can see that. So this is my copy of Diskkeeper that I have running on my machine. So in both Diskkeeper and Velocity, you get this dashboard report. So that shows you how many storage I/O transactions have been eliminated from actually having to go out to the storage, how many reads have been eliminated, how many writes have been eliminated, how much storage I/O time has been saved. In both Diskkeeper and Velocity, you get the I/O performance information, so the average, minimum, and maximum for things like the I/Os per second, throughput, storage latency, whether you're more read-heavy or more write-heavy, how much storage workload has been processed, how much RAM is free for caching, and how much has been used for the cache. In both products, you see this analytics section, which will show you at different times of the day things like when you're eliminating more of that storage traffic from having to go out to the storage. And that's broken down into reads and writes. You can see how much storage I/O time is being saved at different times of the day, where you're preventing and eliminating the fragmentation that causes those split I/O situations, what the IOPS looks like, and so on. But the extra report that you get in Diskkeeper that you don't have in Velocity at the moment is this system monitoring report. And this is really intended to be a sort of troubleshooting tool. It will show you over the last 7 days what time of the day you've been using the processor more heavily, what time of day you've been using the storage more heavily, and you can see the processes running in the machine that have the highest resource utilization and the file types as well. So if I want to see which processes running on my machine have been hammering the processor the most over the last 7 days, well, I can list them out. If I want to see which processes running in the machine have been using the storage the most, I can list them out in order as well. And I can see which processes have been causing the most performance-losing split IOs as well. Thankfully, those are not particularly large numbers because I'm using Diskkeeper on my machine. And I can do the same thing with file types as well. So you have that in Diskkeeper, but you don't have it in Velocity at the moment. But all of the other reporting is in both versions of the product. So I hope that answers that one. Let me get back to the questions here. Does this technology, or is this technology usable on Oracle systems or only SQL? Emil asks that. Good question, Emil. Absolutely, it runs on SQL. That's a particular sweet spot for us. If you have Oracle running on Windows, again, that's a particular sweet spot for us. If you have Oracle running on Linux or some other non-Windows operating system, we can't help with that. The software is only designed to be installed on Windows machines. Excuse me. So that's Windows servers, physical or virtual. You can even put it onto workstations, laptops, tablets, that sort of thing if you want to as well. But it has to be a Windows system. In terms of database technologies, I've personally used it with things like SQL, MySQL, MariaDB, Oracle, and it always gives performance gain and improvement and benefit. You know, it's having that storage I/O reduction is really helpful to most database technologies, even things like older things like DBase and things like that. The more you can reduce the workload on the storage, the better everything's going to run and the more efficiency you have in the environment. If you think about your IT estate as a stack, you know, you've got your back-end storage at the bottom of the stack. In the middle, you have your server, which has your processor, your CPUs in it. And then above that, you have the applications that you're running. If you compare the speed at which things can happen at the storage layer to the speed at which things happen at a processor layer in the CPU or even in server-side DRAM, that storage is always going to be the slowest link in that chain. Even if you have an all-flash array or a tray of SSDs sitting in the tier 1 of your SAN, that's always going to be slower than the processor layer or the RAM layer. So the more you can reduce the workload on that back-end storage, the better everything's going to run. So I hope that answers that question. Yes, you can use it on Oracle systems as well. So Ronald van der Newt asks, what is the minimum MTU size for the communication between ESXi host and storage? Good question. I don't know is the short answer, and I apologize for not knowing. The reason that I don't know is that the packet sizes are figured out by our telemetry. So we're not saying that in every case a larger packet is a more efficient packet. Typically that is the case. I mean, that's why you would typically try and use the sort of larger MTUs that you can. But not every application works the best with these larger IOs. The point I'm trying to make is that the telemetry that we have in our technology actually bothers to learn and find out what the right packet sizes are that are going to give that application, that main application that's running, the best performance. And then if the way you use that machine changes over time, that telemetry will allow our software to automatically adapt to those changes. So you don't have to go in and reconfigure anything. It will automatically adapt to those changes in workload and those changes in usage rather, so that yes, we can still figure out what to get into the cache and when, and also how best to size those storage I/O packets to give the storage and the applications the best performance. So I'm sorry, I know I haven't answered that question directly, but I hope that gives you at least an excuse as to why I couldn't answer the question. Okay, so a couple more questions coming in, and well, I know we're overrunning a little bit, so I really do appreciate you guys staying on. I hope this is useful info for you. Okay, so Axel is asking, coming back to my big question before, if V-locity is installed only inside the VM, can it conflict with Diskkeeper 16 for optimizing or controlling the physical disk layer, or any other third-party caching software like Intel CAS, cache acceleration software, or Primo Cache, for instance, on the physical server? For the physical server, the VM is more or less an application running, accessing data like any other application does, or do you disagree? Okay, no, I don't disagree. In fact, let me share my screen again, and I'll bring up a slide that will help me explain my response on that. I think in this one, I have a little slide here that shows exactly where we sit in the stack. Here we go. Okay, so this is effectively the IT stack in a virtualized environment. In the middle here, you've got your physical host hypervisor and your host server. So this is your ESXi box or Hyper-V server, what have you. You've got your storage on the back end, and we've got a virtual machine being hosted. We're doing all of our operation here up in the guest Windows operating system layer. So if you have other I/O acceleration technologies, other storage I/O acceleration engines, it should be very complementary with them because we're already optimizing and reducing the traffic first. So if you have a cache sitting down here in the physical host, Let's say, for example, you've got Primo cache running on the physical host, or if you have something like a Fusion I/O card, a PCIe flash card or an SSD sitting in the physical host, or if you've got a tray of SSDs or some other storage layer cache, it will be very complementary with what we're doing here right at the top of the stack. Because up here, we're effectively being your tier 0 caching strategy. We're caching first, so that everything below that benefits from having less workload to deal with, because we've already offloaded some of it, and the workload that it does get to deal with has already been optimized typically into these much fewer but larger I/O packets so that they can run more efficiently as well. So not only should it be very complementary with those other technologies that sit further down the stack, we should make those guys look really good as well by optimizing the workload that they do get to deal with. So I hope that answers that sufficiently. If it doesn't, feel free to come back to me on that. So Daniel Jacquier says, any performance improvement to expect on backup jobs with Veeam? It depends. I know that's a bit of a woolly answer, but there are a lot of variables involved there. And it really comes down to where is the current bottleneck. Certainly we do have many customers coming back and saying, yeah, you've cut our backup elapsed time on things like Veeam, Backup Exec, and others significantly. You know, the people come back and said, yeah, you've shaved 25% of our backup time, which is great. Does it happen in every instance? No, it doesn't. It does happen fairly often, but it's not going to happen in all cases. It really depends where the bottleneck is. We can make the storage that you're reading from, for example, much more efficient and run much faster, but you may still be bottlenecked between the connection between that server and the backup server. And the data's still only going to flow as fast as that link between the two servers will allow it to. So oftentimes, yes, we do shave time off of backups with things like Veeam and others, but you're not going to see it in every case. It really depends where the bottleneck is. So there you go. That's a proper engineer's answer rather than a marketing or sales guy's answer. Okay, are there any other questions here? Oh, here we go. Here's one from Rui Borges. Will this software also improve SSIS packages performance? I don't know. Forgive me, I'm not sure what an SSIS package is. I can't answer that without finding out what that is. So again, what I'm going to do is take that one offline, and I will get back to you once I have found out. Again, I'm not going to sit here as an engineer and try and bullshit my way through an answer. I would much rather find out and get back to you with the real data. So forgive me. I mean, if the SSIS packages are for Windows and are particularly storage intensive, then yes, there's a very good chance we can help. But I'd like to find out a little bit more about that before being able to offer a proper answer. I hope you understand. Oh, forgive me, Rui. Okay, he's kindly mentioned SQL integration services. So again, I'm not familiar enough with that. I will need to find out and get back to you. So I will do it that way round if that's okay, Rui. Forgive me. Most questions I can answer, but if I get caught out like that, I would much rather find out the real data, the real answer, and get back to you with that. And that is precisely what I will do. Okay, I think that is all of the questions that I can see. Forgive me if I haven't answered all the questions. I think I've covered everything, but as I say, I'll put my email address in the chat box again. So if you do have any other questions, you are very welcome to contact me directly, and I promise to respond to all of them, and the couple that I haven't been able to answer in this session. If you want to get a hold of the trialware, reach out to me or request it through the website, or reach out to your regional rep, and we will make sure you get a copy of that. If you want the I/O assessment tool, again, let us know and we'll provide that to you and help you step through the results if you want us to. So Oh, final thing, everybody, I think I mentioned this already, but everybody is going to be getting a full free copy of our software to run on one of their servers so that they can check it out and really see what the software can do. But remember, if you really want to do a proper proof of concept, try and get the software onto as many machines as you can that share that same shared storage. That's really where you're going to see best results. So that being said, I just wanted to say thank you to everybody for attending, and thank you for staying on. I know we went over a little over time, but yeah, I really appreciate it, and I hope the session has been helpful and useful. So thank you, everyone. Take care. Have a good day, and I hope and look forward to speaking with you all soon. Take care.